Hi, I'm Bill Armstrong with Fluid Handling. What we're going to talk about in this video is a couple principles that affect pump selection in applications where you have a significant amount of air entrained or dissolved in the water. And that would typically be a cooling tower application because the way a cooling tower works is results a lot of air in the water. Those two principles are Henry's Law and Boyle's Law. Henry's Law basically says that as the pressure is reduced on the fluid, less dissolved gases can be dissolved in the fluid. So they will start to come out of solution as we reduce the pressure. And Boyle's Law says as we reduce pressure, the volume of any gas increases inversely proportionally to the absolute pressure, meaning as the pressure goes down, the volume of that gas will grow. So if you have a bubble, the bubble will get larger. And as I said, the application for this is in cooling towers where we have a lot of dissolved air that we can't see and entrained air, which may be in microscopic bubbles to larger bubbles. But when that fluid enters the suction side of a pump, there's a sharp pressure reduction, and we're going to do a little experiment to show you what can happen when we have a fluid with some dissolved gas in it. The fluid we have is some kind of flat carbonated water. This is about a year-old carbonated water, and we're going to subject that to low pressure and see what happens to it. So we're about to do a little test here using a bell jar. Let me get that set up for you. What we have here is a glass of fairly flat carbonated water. It does have some bubbles that are pretty inactive, as you can see. And we have a bell jar. And the bell jar is a device in which we can draw a vacuum using an air jet ejector. This is connected to a compressed air line. So let's put the top on the bell jar. We'll start to draw a vacuum. And what you should see is some of the dissolved carbon dioxide coming out of solution. And as I continue to lower the pressure, that is increase the vacuum, hopefully you'll see the bubbles grow in size. So let's get started. Okay, now you can see the bubbles begin to come out of solution. And as you can see, as I get lower and lower in pressure, those bubbles become larger and larger. So that's Henry's Law and Boyle's Law working together. In our experiment, we showed that according to Henry's Law, dissolved gases will come out of solution. And according to Boyle's Law, the volume of those gases will increase, resulting in some larger bubbles. The application for that in our industry is when we're pumping water from a cooling tower that has a lot of dissolved gases. The gas would be air in that case. And as the water enters the suction side of the pump, we have a pressure reduction, which results in some of the same things we showed in our experiment. This is all discussed at fluidh.com in the technical section of the website in a paper called Cooling Tower Pumping Considerations. So take a look at that, read more about it, read how to avoid problems resulting from these two principles. Thank you.